All right, so here we go with part C. Part C says at time t equals 0 seconds, the height of the water is 5 feet. All right, so right there they give me an ordered pair when t equals 0, h equals 5. So I'm going to note that. Use separation of variables. Now right there I want to think differential equations. And they kind of hit it within another problem, but that's really what they're asking you to do, is to find a specific solution for the differential equation that we're given in this problem. All right, now we know dh dt equals negative 1/10 root h. All right, and they've told us to use separation of variables, so they were very directive here. So I'm going to divide both sides by root h, all right, which means that I have h to the negative 1/2 on this side. I'm going to leave the dh put, but I'm going to multiply over the dt. So on this right-hand side, I have negative 1/10 dt. All right, from here, all right, I've separated my variables. So I'm going to take the antiderivative of both sides. So on the left-hand side, I raise the exponent by 1. It becomes a half. I divide by a half, which is the same as multiplying by 2. So I have 2h to the 1/2, right, equals negative 1/10 t. And then we're going to consolidate both constants, and we're going to move it right over to this side. All right, now on this problem, I'm going to go ahead and choose to put in my 0 and 5 now, and find out what that c value is so that it's easier for us to work through the rest of the problem. All right, so we know that we've got 2 root 5, right, because it was h to the 1/2 and h is 5, equals negative 1/10 times 0 plus c. All right, and again, I'm just plugging in the ordered pair that I know for this particular problem. All right, at this point, I'm going to go ahead and I'm going to we've got 2 root 5 equals c, because that goes to 0, the negative 1/10 times 0. And now I've got my constant. So I'm going to bring that back. And that gives me 2h to the 1/2 equals negative 1/10 t plus 2 root 5. All right, now this very explicitly said find an expression for h in terms of t. So I need h by itself. So I'm going to divide both sides by 2. So I have h to the 1/2 equals negative 1/20 t plus root 5. And then I'm going to square both sides. So h equals the quantity, negative 1/20 t plus root 5, all right, quantity to the second. And that would give me a function for h in terms of t, which is exactly what they asked for. So again, this was our differential equations question. We had to separate the variables. Once we did that, we had to integrate both sides, find the constant, and then once we found the constant, often, most of the time, we're going to have to solve for one of the two variables. Because they're typically going to ask, right, y is a function of x, y equals f of x, or like they did here, h equals some function in terms of t. So that's the typical rundown for differential equations, and that was part C from problem number 4. All right, I hope these explanations helped. If you have any other questions, don't hesitate to fire me an email. Most of our time on Thursday will likely be devoted towards problems 5 and 6, which are being assigned on Wednesday. I hope this helped. Bye.